One of the amazing advancements in modern science is the development of spectroscopic technique. This technique allows us to have structural and compositional information of materials under study. The results obtained are in the form of graphs, called spectrographs or molecular spectra. We get these graphs due to the interaction between electromagnetic radiation and materials. Electromagnetic radiations are simply the waves carrying information about the electromagnetic field. Both the electric and magnetic fields oscillate together perpendicularly to each other. Electric or magnetic fields indeed are nothing but regions of space around an object up to which it can exert its force. It is an already established fact that both electrical and magnetic fields are intrinsically related. Because of this phenomenon, we've been facilitated with electromagnets, electrical currents, and several other applications. James Clerk Maxwell gave a theory which implied light to be an electromagnetic wave. Further, electromagnetic radiations come in various shapes and sizes. Some are detectable with our eyes and are called visible or optical. Others, however, can't be seen with our eyes, such as infrared, radio, X-rays, ultraviolet, and gamma rays. Thanks to Bohr and Planck, we can infer molecules of quantized energy levels. That means these energy levels have specific energy associated to them. When these molecules interact with electromagnetic radiation, there are three possible phenomena that could take place. Firstly, if electromagnetic radiation transfers its energy to the molecule gets excited to high energy levels. This process is called absorption. The resulting spectral lines as a function of wavelength of radiation is called absorption spectrum. Secondly, when molecules are excited to high energy levels, eventually they'll fall back to lower levels. This transition of energy is called emission if the radiation field receives the emission energy. If transition occurs without emission of radiation, it is called nonradiative decay. These emitted radiation signals will result in emission spectral lines. And finally, if light interacts with matter and redirects itself, then this event is called scattering. This process may or may not involve the transfer of energy. So scattered radiation will have slightly different or same wavelengths as that of the incident light. Depending on the shift compared to original light, these scattering have different names, such as Rayleigh, Brillouin, and Raman. Hence, transitions between energy levels in molecules are caused by either of these three phenomena, that is, absorption, emission, or scattering of radiation. But these processes, however, are also subjected to certain rules. They are known as selection rules. These processes will eventually result in spectroscopic lines of different shapes, spacing, intensities, and frequencies. These will in turn reveal molecular parameters like concentration, symmetry, bond lengths, moment of inertia, etc.